All right, so second lesson, what we're going to talk about today is combining like terms, right? So we already talked about the distributive property, right? We've got the two ways that we talked about distributive property right up here at the top. So we've got the distributive property over addition and then over subtraction, right? And really all that's going on with those is that we're taking whatever's on the outside of some parentheses and we're, distributing it, like putting it out to each thing on the inside. When we do that, we're multiplying, right? So we have a times b in the red on both of these. For the 1 over addition, the one up top, it's a times a positive c. So we get positive ac with a plus sign. For the 1 over subtraction, it's a times negative c, right? Remember we talked a little bit about, grouping it with that sign that comes right in front of it, which is why we have negative ac, right? Because there was one positive times one negative gives us a negative. All right, so what we're going to take a look at today is kind of like an extension of the distributive property, right? Something that you might have to do after you distribute. And that's combining like terms. So combining like terms, you have to figure out what like terms are first, right? They're terms with the same variable and exponent, right? You need to have both. It needs to be variable and exponent that match. Right? If those two things don't match, then you can't do it, right? As far as variables go, right, obviously, that's like you could do x plus x, right? That would be fine and dandy, but you cannot do x plus y, right? Those are not like terms, right? So that's something to keep in mind. As far as exponents go, right, you could take x squared and add another x squared to it, right? That works out just fine. But things get a little hairy when we try and take x squared plus like x to the fifth. Those are different things, right? If I have x squared, that's talking about a very particular quantity, and x to the fifth is not the same thing, so you can't just smush them together. All right, so we'll get a little bit further into what that looks like when we do that. When we're adding and subtracting like terms, we also need to pay attention to the coefficient, which is just the number in front of a variable. It has hidden multiplication. And what I mean when I say that is that if you have 3x, that really is the same thing as 3 times x, right? It's telling me, all right, there's this thing, x, and I have 3 of it, right? So it's 3 times that much, right? We just shortcut it and write it this way over on the left, right? Just as 3x. Okay. So some examples of like terms and some examples of unlike terms, right? So like terms could be like 2x and 73x, right? Those are just fine. But I could not have, 5x and 17y, right? Those are not like terms because they don't have the same variable. All right, what if I had, 8a to the third and 14a to the third? Those are like terms, right? They have the same variable, a, and they also have the same exponent, 3. All right, but that might not work out so well. So let's say that I had, 2a squared b to the third and negative 5 a to the third b squared. All right, this one can get a little tricky, right? So the 2 and the negative 5 doesn't even matter when we're talking about like terms, right? To figure out whether they're like terms, we're looking at the variables, right, which do match, right? They both have an a and a b, so that's good. So what we're then looking at are the exponents. And you might be thinking to yourself like, oh yeah, there's an exponent of 2 and there's an exponent of 3. Everything's fine, right? We got like terms. Sorry to say, that's not the case, right? So when we have these exponents, they need to be on the same variables, right? A squared should match up with the exponent for the other a. The fact that those don't match means that these aren't like terms. The same thing is true for the b's. This is b to the third, and this is b squared. That doesn't work. We cannot combine those because they don't match up. Right? So it can get a little confusing sometimes. All right? Let's say that we had something like, actually, how about this? Pause this here for a second. See if you can come up with some other like terms that might look a little different than the ones we've done before, and some unlike terms, and see if you can figure out which is which. All right, I'm going to throw another example up on mine. let's say that we had negative 7.2 x to the fourth y to the third z, and 1 x to the fourth y to the third z. Let's get that little extra dot out of there. That's not supposed to be there. Oop. All right, those are like terms, right? They look kind of gross. I don't really want to have to deal with negative 7.2 of those things, right? But they have the same variables, they have the same exponents, they match up just fine, right? If I had something like 21xy and 31x squared y squared, again, same thing, those don't match. And actually, I'm going to edit that one a little bit. Let's say that we had something like this. We had 21x squared y squared, and then 31x squared y squared z, right? The fact that this one has a z and this one does not means that those are not like terms. They need to have every single variable and exponent match. Okay. So let's take a quick sec. Let's figure out if these are like terms or not. All right, 3x and 2x. All right, so again, I'm looking at the variable, they match, and they have the same coefficient, which is, it appears to be no coefficient. There is an invisible 1 there, right? So those match. So yes, they're like terms. As for 4x squared and 3x, right? Again, I'm looking at the variables. They both have x's, but then I'm looking at coefficients. That one has a 2, and this one has an invisible 1. So that one's a no. All right, if we have 2xy and 4xy squared, right, the variables match, but then these exponents on the y's do not, so that's also going to have to be a no, right? When we're getting things that aren't like terms, that means that I can't just like add them together or subtract them from each other, right? I could go ahead and I can multiply and possibly even divide them, but when we're talking about combining like terms, it's specifically adding and subtracting. All right, how about these ones for D down here? 4x squared y and 8x squared y. I mean, all the variables match up and all the exponents match up, so that one seems like a yes to me. All right, and then last but not least down there, again, take a second, pause here if you need to, take a look at those and see if they should be like terms or if they're not. What I'm noticing is they do both have xy, right? The variables on the x's match, but then the one that's on the y's do not. Right, so this one's a no, unfortunately, right? Those are not like terms, even though they seem to be real close. Okay. One way that we can use combining like terms in geometry, especially, which is something we're gonna, you're gonna be getting to later this year, is talking about perimeters of shapes. Right. So sometimes you might not have measurements when you're finding the perimeter. So just as a quick refresher, to find the perimeter of a shape, you might remember this, but all you have to do is add up all the sides. All right, so to add up all the sides, all I'm going to do is I'm just going to start somewhere and keep on going around. So let's focus on the left one first. What I'm going to do is I'm going to start up here, and I like to go clockwise after that, so I'm going to go around that side, making sure that I hit every single side along the way so I don't forget anything. All right, so I'm going to have 4u, and then I'm going to add on the next side, which is 2t plus u, and then I'm going to add on the next side, which is 7t, and then I'm going to add on the next side, which is 5u minus t. Right? So you might notice that each one of these was its own side. Right? So again, start somewhere. If it helps, cross them off as you write them down when you're adding them together, right? That way you can make sure that you didn't miss any. When I'm going ahead and combining these like terms, I'm looking for things that have the exact same variables and exponents on them. So one way that you could do that, is you could highlight them if you have a highlighter with you. You can put different numbers of lines underneath them. Like, for example, 4u, I could put 2 lines underneath that. That should go with this other u and these 5 u's, right? Something like that. I think on here, I think it'll show up best if I use a highlighter, so I'm going to do that. So again, I have 4u over here. I'm looking for anything else that is a like term with that. So this u by itself matches up with it. And so does this 5u over there. You might notice for those other two that I grabbed the plus sign in front of it, right? Because just like when we were distributing the other day, we want to grab the sign in front because that does kind of inform us as to whether we're adding it or in some cases we might be subtracting it. Right? So all those things in yellow are like terms. Then we move on to the other stuff, right? 2t matches up with 7t, right? So we got a plus sign there. And then it matches up with this minus t at the end. All right, so again, we're grabbing the signs that come in front because that's telling me what I should really be doing for my answer. So let's do the stuff in the yellow. I had 4 u's, and then I'm going to add another one on, so I'm up to 5 u's. And then I'm adding those 5 more on at the end. So altogether, I'm going to have 10u. All right? Ooh, and I forgot I had this tool. Over here, I've got 2t, and then I'm going to add on another 7 to get 9. So I have 9t, and then I need to subtract that last one, so that'll bring us down to 8t. And it's a positive 8t. All right? So what's in blue is what we got from the terms in blue above. What's in yellow is what we got from the yellow. All right? Once we get there, that's all we need, right? Our terms have been combined appropriately. That is the perimeter of that shape. All right? Let's try with something a little different, right? This one's got a couple different variables in it. All right? So again, what I like to do is I like to start in one place. So I'm going to start at the top again, and I'm going to go around clockwise. All right? And what we're going to do is just, write them down first, and then worry about finding the like terms. So we got 3w. I'm then going to add on the next side 2w plus y. I'll add the bottom, which was 4y. And then I'll add that left side, which was 4y, y minus 2z. All right. So I've got all this stuff on here. Now I need to find the like terms. So again, I've got 3 w's. I've got another 2 w's here that match. And that's all I've got for w's. All right. Then I've got a y plus 4 more y's. Plus 4 more y's, oh my gosh. And that's all the y's I've got. And then minus 2 z's on the end. All right, so I'm not saying that you have to do this every time, like putting lines underneath them or highlighting or whatever. Right? Once you get better with this, do it in your head. That's perfectly fine. Add them up as you go and stuff like that. But, it's not a bad idea to, take it easy at first. So when I'm combining these like terms, right? 3 w's plus 2 more w's is going to give me 5 w's. All these y's, when I add them together, right, I had 1 in the beginning, right, that's 1y, plus 4 more, and then plus another 4 more, brings me up to 9 of those total, so plus 9 y's. And then that minus 2z on the end just stays as minus 2z, right? It didn't have anything to combine with, so we bring it down just as we found it. All right? And that's what we're looking for. That's when we're combining like terms. We have now found the perimeter of that shape, and we're good to keep on going through whatever problem that relates to in the future. Okay, so hopefully it doesn't seem so bad. Let's take a look at some problems that, obviously start out looking a whole lot worse than what we were just doing. So this one wants us to use the distributive property and then combine like terms. All right, so let's take it one step at a time. If I'm looking at this problem, I'm noticing that over here, there isn't really anything to do, right? There is no distributive property that I have to do for that first set of parentheses. So honestly, what I'm going to do is I'm just going to bring it right down. 4x squared plus x plus 9. All right, cool. Done. After that, I'm taking a look at this second set of parentheses and how we've got this positive 10 that I'm going to then distribute into there. All right, so I'm going to do 10 times that 12x. So that's plus 120x. I'm then going to move on to the second piece. So we've got 10 times negative x squared. Right? So again, from last time, we know that there is a little 1 in front of that x squared. So we can do the 10 times that negative 1, which gives us negative 10. And then the x squared comes along for the ride. Last but not least, we're going to take that 10 and multiply it out to that negative 3. So we're going to end up at negative 30. right? So now we're able to combine our like terms, right? We've got some things that can match up together, right? So I'm going to show you guys that other way I was talking about where you can just use different numbers of lines underneath. So 4x squared matches up with these negative 10x squareds, right? So I know that I can combine those when we get to that. This x by itself matches up with these x's that don't have an exponent on them. They're just regular old x's. And then this 9 matches up with this negative 30. All right, so that is another way that we can identify which ones are like terms. Obviously, the highlighters might be a little bit clearer if you have them, but this is an okay way to do it as well. So when I'm combining these like terms, I'm going to go with the stuff that has the highest exponent first and then kind of keep on going down from there. It's not really a huge deal no matter how you write it, but that's what I'm going to do here. So what I'm looking at first are these x squareds, right? So I got 4x squared and minus 10x squared. So if I had 4 and I subtracted 10, I'm down to negative 6 x squareds. Right, I'm changing how many of them I have. I'm not changing what the x squareds are. I just now have negative 6 of them. Right. After that, I've got this plus x and this plus 120x. Right, so there was 1x right over there, right? Remember that does have a 1 in front of it. So if I had a single x and I added 120 more, I've got 121x. Last but not least, I've got this 9 and this negative 30. So if I had 9 and I subtract 30 from it, I'm going to end up at negative 21. Right. And this is what we're looking for. Ding. So I know it seems like a lot of steps. They do start to go faster the better you get with this stuff, right? So the more you practice, the easier these will be, which is true with a lot of math. All right, let's try another one out. Actually, how about this? Pause here, try this one out on your own, see if you can do the combining like terms piece as well, see what you get, and then unpause and come back to this, right? See if you get it right. All right, so what I'm going to do here, right, is I'm noticing that this first set of parentheses here, again, just like the last one, doesn't have anything for us to do with it. So I'm just going to bring it right on down. 3x squared minus x plus 2. The second set of parentheses has this positive 8 that we're then going to distribute in there, right? So that's going to be plus 32x. We got a minus sign there, right? So that's going to end up being minus 8x squareds. And then plus 40 on the end. All right. Now I got to figure out what our like terms are. All right, so I've got some x squareds and some more x squareds over there. I've got a regular old x and some more regular old x's. And then I've got a plus 2 and a plus 40. All right, so that's going to help us organize things. When I'm looking at the stuff in yellow, those x squareds, if I had 3 and then I'm taking away 8, I'm now at negative 5 x squareds. Again, not changing what they are, just changing how many I have, right? That coefficient is changing. Then if I'm looking at the x's in green, I had negative 1x, and then I added 32, so I'm going to end up at positive 31 x's. And then as for the stuff in the blue, we got 2, and then we're adding 40, which is 42. All right, and again, once we get here, that's all we're looking for, right? We distributed, and then we combined like terms, and then we're done. Okay. These last ones get a little trickier because you got a little bit more going on. Right? So on this one, you'll notice that we have a 4 out in front of this set of parentheses and a negative 2 out in front of that set. All right, so something that I notice people make mistakes on is that they'll take this 4 and they'll like distribute it to those, and then they'll keep going and they'll just distribute that 4 out all the way to the end of there. Right? That's not what we want to do. When we're distributing, it only goes out to the parentheses that it's next to, right? So that 4 only goes to those 3 other things. This negative 2 is going to go to the other ones in the other set of parentheses. All right, so we're going to kind of run through this. 4 times x squared is 4x squared. 4 times 2x is going to give me 8x, and it's positive still. 4 times negative 4 is negative 16. All right, so that's what I'm going to get from that first set of parentheses. Second set there, I have negative 2 that I got to be a little careful about. So negative 2 times x squared is negative 2x squared. When we do negative 2 times positive 3, that's negative 6, and the x comes along for the ride. And then we have negative 2 times negative 5, which is going to end up with a positive 10. All right. So a little bit more distribution to do there to get things rolling. Right, but then after that, it's just combining like terms, easy peasy. I got some x squareds that match up. We've got some regular old x's that match up. And then we've got some regular old numbers, right? Sometimes I have people that forget that numbers are like terms, right? Like 16 and 10. You can still add those, right? We've been doing that for years, right? So don't forget that numbers count as well. You can add and subtract numbers. So the stuff in the yellow, I had 4 x squareds, and I'm going to take away 2 of them. So I'm left with 2 x squareds. For the stuff in the green, I had 8 x's, and I took 6 of them away. So I still have plus 2x. And then as for the stuff in blue, I had negative 16, and then I added 10, tried to dig myself out of that hole, but I'm still at negative 6. Bingo, bango, bongo, that's all we got. Right, hopefully it doesn't seem so bad. Okay. What I'd like you guys to do is, again, pause here, try this one out. It does have a little bit extra going on, right? You might notice that this one has an X when it's going and distributing. So try that out. We did a little bit of that yesterday. See if it comes back to you. If you get a little bit stuck, it's okay to unpause and come back and see what I'm doing. All right, so what I'm going to start off by doing is saying, like, all right, I got this negative 3 over here that I'm going to distribute into this first set of parentheses. And then I've also got this minus 5x that I'm going to distribute into that second set of parentheses. All right, so let's start with the stuff in red. Negative 3 times x to the third is negative 3x to the third. When I do negative 3 times x, that's also negative 3x. Right? Because again, don't forget, these have little ones in front of there. It's the negative 3 times the 1 that gives us those. Right? Most of the time you won't see them there, right? But they are still technically there if you want to remember them. And then last but not least, we got negative 3 times negative 9, which is going to turn out to be positive 27. All right, cool. So the red stuff's done. Then the blue is where it gets a little trickier, right? It's pulling some stuff that we worked on last time. We have negative 5x times x squared. All right, so the negative 5 is just kind of doing its own thing, right? It's negative 5 times, again, that invisible 1 that's hanging out. So it just stays negative 5. And then x times x squared, right? So what's going to happen there is that, imagine I had x times x squared. Well, don't we know that x squared is the same thing as x times x already? So what I can do is when I have something like this, I could go ahead and I could rewrite it a little bit differently, right? It's x times the x squared. Right? That's what that x times x was. So if 2x's multiplied gives me x squared, then it should hopefully make sense that 3x's multiplied together gives me x to the third. Right? So we're just kind of ticking up that variable by 1 because we're now multiplying by an extra x. All right, so we'll get 5x to the third there. All right. After that, last bit's not too bad. We got negative 5 times negative 9 gives us positive 45. And then that x comes along with us. Okay. All that's left is like terms, and then we're done. We've got some x to the thirds that match up with these other x to the thirds. We've got some regular old x's that match up. And then we got 27, which is all by itself. So sad. Makes you want to cry just a little bit. Just a little bit. All right, we can keep going. So, stuff in yellow. I had negative 3x to the thirds, right? It's like I owed somebody 3 of those things. And then I'm subtracting another 5. So altogether, I'm going to get to negative 8x to the thirds. Stuff in green, I had negative 3x's, and then I'm adding 45. So I'm going to pop up to be positive 42x there. And then thankfully, that 27 hanging out by itself makes things nice and easy for us. We just tack it on to the end, plus 27. All right. And honestly, that's it. I'm hoping that this made sense. If not, be sure to ask me when you see me in person. We're working on problems for these. Just a reminder again, you do not need to do the practice problems that are at the end of the notes. Where that's what we're going to do when I see you during class. And I guess that's it. I'll see you guys later. Whoops. Oh dear.